So we made an app named HAut, and in this app we upload an image of the infected area of the skin, and the app will use a TF-Lite model to produce results. By results I mean it will tell the user what kind of disease the user may be suffering from. So this is the app, this is navigation drawer. If I click here I can know about different types of skin cancers, and this is the about us, a simple fragment. This is the home fragment. If I click on this plus sign and I select an image, if I click on predict, this will be the prediction. It will tell what kind of disease I may be suffering from. Then I can click on read more to know more about the disease. I can click on consult and specialist to know more about doctors which can treat this kind of disease. And yeah, this is the app.
So this is our app HAut, which is falls in the category of public health. It is a skin cancer detection app. HAut basically means skin in German, and it is a Codathon project proposal, and the team name is Sigmoids, which actually represents an activation function in neural networks. Moving next. We have table of content, 1 problem statement and solution, 2 the novelty, 3 the ML model and app, 4 UI UX mockup, 5 the demo, 6 developers. First, problem statement and solution. So nowadays everything is digitalized and works on the concept of go online. So because of the pandemic, people don't usually prefer to go to the doctors for any kind of doubts in the symptoms. So what our app can do is we plan to build an Android application integrated with deep learning convolutional and neural network trained on image data set of skin cancer images. So if any user has any doubt of any skin related issue, do not have to go to the doctor directly in pandemic period and get the idea of what the issue may be. The novelty. And so in the current era, we do have apps like Procto, which recommend doctors on the basis of symptoms and the tell you by clicking options. But the thing is, it works on the user experience of the symptoms, which can vary from different person to person, because of the perspective. But here we use images that is 10,000 images with a diversity on real world data. So it is it has less chances to go wrong. So next, the ML model plus so our tech stack is Python, TensorFlow, NumPy, Pandas, Matplotlib, Seaborn, sklearn, Keras, TensorFlow Lite, Java, XML, and Figma. So ML model we did using Python libraries, and we have chosen a dataset with following skin disease labels. And ML model, this is the architecture of our ML model, which I will also explain in depth in the Python notebook. Now the Java XML app part, it takes the TensorFlow Lite model as input and then predicts the probability of the disease and also recommend you doctors. And it has a home page with different diseases summary. Next, our process is click or upload image on Android app, predict the disease using TensorFlow Lite model in the backend, display the probability of the skin disease, and recommend skin specialist. UI UX mockup next. So this is our wireframing prototyping of our app we did on Figma. So the first display the summary, then the next is display upload the image. If upload fails, it displays that upload failed. If gets, then it displays the image uploaded, and we can click the predict button, which displays the disease and also a circular ring for the probability. Then we can consult a specialist which recommend us doctors. So next, the demo that is we are shooting right now. So the developers are Ritik Purwar, me, who is ML and DL enthusiast and UI UX developer, and Rahit Singh Nanda, who is Android app developer and UI UX developer. So thank you. Now we will look into the Python notebook, then the Figma prototype, and then the uh, Java files, the Android files, and finally the app demo video. So this is the prototype we have made on Figma. This is the first page, then this is the second. On upload it goes here, and on without uploading image, when we click predict it goes here, and then we upload image. This is the, and then when we predict, uh, click on the predict button, it predicts as this circular ring the disease, and we can read more about it. And when we click on consult a specialist, shows us the recommended doctors. This is the prototype. So first of all, we will be looking into the Python notebook file of the code of our project. So for this project, we got the MNIST data of skin cancer images of RGB 28 cross 28. So first we displayed the data. It is of 2351 different pixels, that is 28 cross 28 cross 3. Then there are 7 unique labels, and we saw whether there are some any null values. So there are none. Then we splitted the data as x and y, and then we saw the value count. So this is very unbalanced data, that like one is 6700 plus and the other is 115. So this is unbalanced data which can usually impact our model. Mm, Next is our dictionary. We created a dictionary of different numeric labels to disease labels. Then we again by another method we displayed the mm, value count chart bar. Now to balance the data we used IB learn oversampling, right? From that we imported random oversampler and sampled the images, so that the random sample the images. So now it became balanced data set. Now uh, we reshaped the training data as 28 cross 28 cross 3 instead of a single array. So now we displayed a few results, and then we made a CNN model of input size 28 3, then convolutional 2D layer, filter 32, kernel 3D, followed by max pool, followed by convolutional 2D of 64, followed by max pool, followed by convolutional 128, followed by max pool, then 256, then max pool, then 512. Then we added a flatten layer, then dense layer of 128, followed by 64, followed by 32, followed by 7 of softmax, that is output layer. We display the model summary. Then we trained the data on box. We got an accuracy of around 75%. That is because of the lower dimensional data we got. As we will get higher dimensional data, it will get much more improved. Now we trained the data and then tested the data and draw a confusion matrix, and just tested on one of the image here, and then exported it as TensorFlow Lite model, which will be used in the as integration in the Android app. So this was the Python notebook part.
Okay, so this is the Android project for the Android app, and the as we already told that our project will be done using the Android Studio IDE, and languages which we are using are Java and XML for our development purposes. So these are the Java files, these are the XML files for our layout stuff, and in this ML folder we have model.tflite, and this is the TensorFlow Lite model which we will use to make predictions in this app. and this is the fragment one. The fragment one is the most important fragment in this app because it has the code which is responsible for the TF light part, where we take the image from the user, and that image is used by TF light to make predictions. By predictions I mean the disease which the user may be suffering from. This is the code for that TF light part, and this is the important fragment. The fragment 2 is all about displaying different types of diseases. So as you can see, I am just taking the data, adding it to a list, and then adding it to adapter, and then to the recycler view. These three Java files are for recycler view itself, and then we have fragment 3, which is nothing but displays, which does nothing but displays the name of my name as well as my partner's name. And doctor activity will have different type, will have doctor information, and home activity will be the base activity on which fragments will be inflated. This result activity will be used to show the result. So this is the code of result activity. Splash screen will be displayed for 2 seconds when the app is open for the first time, and utils as the data which we will use. And then in the layout part, you can see the XML part. We have layout for different types of activities as well as fragments. This is home. Um, so as you can see, the result one as well, the code for our result XML, and so different types of layouts. We have all types of layouts, and fragment one layout, which is very important. We use this part to we click on this part to upload image, and then press on predict to make predictions. Predict page takes us to this activity.result page where the final result is displayed, and fragment 2 displays the data about different kinds of skin diseases. Fragment 3 nothing about it, but this it is a fragment which is telling about us, the header. And yeah, so the heart of this app, the main part, is this model.tf light which we are using to make predictions in this app. And yeah, so this